versus deep learning, and what are the differences? So today we are joined by Dr. Omran, who will continue after my presentation. But before we start, I would like to ask everybody if you can hear me. Then please write in the chat box, yes. And if you have joined through Google Hangouts, then the chat box is on the right-hand side of your screen. And if you're watching on Facebook Live, then please write in the Facebook comments section. Yes, so good to see that you're able to hear me. And yes, so a quick reminder is those who have joined in through Google Hangouts, please opt to turn off your microphone and video camera during the webinar recording, so as not to disrupt the speaker. And if you have any questions during the webinar, please write them in the chat box on the right-hand side or on the comments section in Facebook. So all the questions will be addressed after the speaker's presentation. So please be patient and wait until the end of the presentation. And the recording of the webinar and also the presentation will be available through a link that I will share later. So you will have to fill out a feedback form. And after filling out the feedback form, you will gain access to our YouTube channel, where you can see also the previous recordings of iTrain's webinars on Industry 4.0 topics. As well, you can access that presentation of the speaker. And I will put the information in the comments section and also in the chat box here in Google Hangouts. So yes, also on Google Hangouts, there's the option to present now. Please don't press that one. That is only for me and Dr. Imran during the session. So yeah, please take note not to disturb. So before we start with Dr. Imran's part, I would like to quickly introduce you to iTrain. And so iTrain is supporting digital transformation, and we are the pioneers and leaders in tech learning in Asia. And at iTrain, we believe in two core principles: the power of technology to shape the future and help us build a better world, and that love of learning is the source of human ingenuity and well-being. And our goal, which is backed by government and academia, is to fast-track Asian businesses with the latest technology applications and know-how. So these are some of the courses that iTrain is currently providing. So we have courses in mobile development, blockchain, data science, Internet of Things, artificial intelligence, which you will hear more today, fintech, digital marketing, cybersecurity. And most of the courses are also HRDF claimable, and we'll be rolling out shortly also online courses and master classes. So make sure to follow us on Facebook to keep up to date on all the newest courses that we will be providing for you to stay relevant in these hectic times. So as you can see, these are some of the clients that we have worked with and helped them to empower their businesses. And as you can see, they're from many strategic sectors such as finance, technology, industry, and manufacturing. So that is it from me. And I will give the floor now to Dr. Imran. Thank you for the attention so far. And Dr. Imran, you can present now.
Hi, very good morning.
Good morning. We can hear you well, and we can see your screen.
Okay. Thank you so much, Elizabeth and iTrain, for giving me an opportunity for presenting about artificial intelligence. Little bit about myself before we proceed with the presentation. I am Adjunct Associate Professor, Dr. Mohammed Imran Server. I'm also industrial consultant for Penang State Government, especially on digital transformation for Office of YB Datu Abdul Halim for International Trade Entrepreneurship Development, as well as I'm co-founder and CTO for Digital Next and co-founder and chairman for Evolution 4.0, as well as associate professor for DRB HighCom University. I have more than 15 years of experience in R&D, industrial solution development, and policy making for smart factory and smart city. So today we will be discussing about something really important. What is AI, machine learning, and deep learning? Because it's very hype word, buzzword, should I say, everywhere. That artificial intelligence will be basically replacing humans in every sector of life, which may be true in some aspect and may not be. And there are some misconceptions about AI and how we will do the development, especially in this phase of digital transformation. And as you can see in this COVID-19 era, that most of the factories are basically closed. This means that Industry 4.0 is basically a necessary thing that if the smart factory compliance happen, then the remote factory can able to run with a minimum input from the human. So how the remote factory will be able to run is basically using AI. And AI itself cannot do anything if it has the access of data. So the data is a fuel for every sector in the digital transformation. So, little bit about uh, Industry 4.0. In a 17th to 18th century, Industry 1.0 era came into being after discovery and mechanism for steam. So, steam engine and relative mechanism revolutionized industry, traveling, logistic, and so on. Then in Industry 2.0 was being formed in the late 1882 when there was electricity was being invented and it revolutionized every way of life. So Industry 3.0 is on automation, where there's a mass production in the factories. But Industry 4.0 is more on smart automation. And when we say about smart automation, it says that it will able to run with bare minimum input from the humans. And when we say bare minimum input from the humans, this means that factory will be autonomous. If the factory are autonomous, this means that they are using artificial intelligence. And when we talk about Industry 4.0, so there are a lot of technologies. The building block for Industry 4.0 and technological pillars starts with IoT, which is Internet of Things. Internet of Things is producing the data, and IoT devices can be sensors, machines, robots, PLC devices in, let's say, in factory, and that data is being transmitted to the cloud. And the cloud is the second pillar where the data is being stored and accessible in anywhere around the world, and you do the analysis. So if the data gets bigger, so you have a big data analytics on the cloud, which is the third pillar, followed by artificial intelligence and machine learning, cybersecurity, blockchain, system integration, additive manufacturing, which is also known as 3D printing, AR, VR, which is augmented reality and virtual reality, and many other technologies. So when they are formed together, they are basically creating an ecosystem of Industry 4.0. And today, in this session, we will be discussing about important pillar of Industry 4.0, which is AI, artificial intelligence, and how AI is different than machine learning and deep learning. So, what is the definition? The theoretical definition of AI is artificial intelligence is a field of computer science that is associated with the concept of machine thinking like a human to perform tasks such as learning, problem solving, planning, reasoning, and identifying. 50 years ago, it was being started. We will discuss about that thing. So, if a machine, which can be a robot, which can be a device, which can be any embedded system that think like a human, act without interaction with the humans, then it is AI. And we are using a lot of applications that are using AI. The most common one is basically our mobile phone, and we are using Waze or Google Maps, and it is basically telling us which route to take from which place to which place in a short span of time. So this decision making happening in the cloud and presenting to us through our mobile is basically artificial intelligence, which use a lot of data. Or AI is not basically a new concept. It has been started way back in 1950 after Second World War, sorry, using the Turing test. So there were a lot of things happen until 1966. Even first robot was being made in this era, and you will be surprised that there was Alisa. Alisa was basically a pioneer chatbot developed by Joseph at MIT. So Professor Joseph developed this, and as you can see, if you open some website like Exabyte or others, so there will be a chat box, and in the chat box, the machine or a software to be specific is basically communicating with you, and it will be very hard for you to differentiate whether you are chatting with human or with the machine because of the maturity. So AI winter is basically a span of time when there was a lack of funding in US and Europe for the AI because government was thinking that this AI may not able to produce any result and it's a myth. But in 90s, IBM was working on AI engine, and in 1997, the Deep Blue, a chess playing computer, which was being developed by IBM, defeated the world chess champion Gary Kasparov. So that was the turning point. And people around the world, scientists around the world, government around the world was astonished that this kind of a capability can be made in software that it can able to compute with the world champion of chess and make a reason and make a step using artificial intelligence to defeat a human. So it was a basically turning point for AI. And then from 1997 until today, there are a lot of things happen. Search engine is basically one of the very common example that with the millions of results, it will show you the most relevant. So AI is basically used in that. Siri, Watson, Alexa are some of the examples, and Google Maps as well. So if I wanted to talk about classification of artificial intelligence, there are a lot of basically classifying attributes or types. They are machine learning is another very important classifier for the AI. In machine learning, we have predictive analytics and deep learning. So what will happen is this that machine will able to perform the task which human is doing, and they can make a semi-autonomous or autonomous decision based on the learning of the data they are having. So this is basically machine learning. So during the data coming every second, so there will be a time that every data will make a machine mature, just like a child. When a child was born, in the beginning, it is just listening to the parents and family, and then formulating a language in and syntax and grammar, and then start speaking the word. And then during gradually the duration of time or passage of time, when a child was being aged, so it is basically getting mature by inputting the decisions or experiences that he or she is facing, and then gradually it will make a decision. But in case of humans, it might take couple of years, but in case of machine, it might take hours or days depending on the data. Then there's a speech. Speech is also an important classifier for AI. Speech means that if I, for example, speak with Google, so my speech, my words is being recorded by the machine, and then each voice is converting into words, and then from that words is basically uh, searching for matching kind of a sentence from millions of word databases or billions of word database to the relevant. So speech to text, and then in the similarly text to speech is basically an important uh, classifier for AI, which is also called NLP. We will discuss later. Then expert system. Expert systems are basically a system which are specialized in some field. Recently, there was a breakthrough last year in China, in which there was a machine uh, that can able to surpass the doctors. So what they do in a live session, they put a medical report of the patients and ask on one side medical expert and on other side a machine to diagnose the disease of the patient through the medical reports, and you will be surprised that the machines were more accurate than the doctors. Similarly, planning, scheduling, optimization, industrial robot or cobot, natural language processing, and vision. Computer vision is basically one of the classifier for the AI. Now, machine vision, the and image recognition. One of the most famous example is Facebook. When you upload a photo, so it automatically you might have hundreds or maybe 1,000 or 2,000 friends or even more. So it will differentiate from the faces. It can differentiate who is basically to be tagged. So this is basically AI in the form of vision. So today we will be discussing about AI ML, which is machine learning, and DL, which is basically deep learning, which we will able to discuss what are the difference between them. So before we go to machine learning and deep learning, let me basically discuss about types of AI. There are three types of artificial intelligence, which is artificial narrow intelligence, which is called ANI, artificial general intelligence, which is AGI, and artificial super intelligence, which is ASI. So based on the intelligence, ANI is stage one, which is machine learning, specialized in one area and solve one problem, like Siri, Alexa, or Cortana. Their basically work is to get a command from the humans and then search accordingly and give back the result. So this is specifically for one task only. But for the computers that are basically perform multiple tasks like humans, they are called machine intelligence, which is stage two. And machine consciousness, which is stage three, is an intellect that is much smarter than best human brain and practically in every field. So right now, people, researchers around the world are basically working on it. What are the top AI use cases we have? We have, for example, customer experience. So let's say based on the feedback of the customers in the website, the feedback, just like Elizabeth mentioned about at the end of the webinar, there will be a feedback. So from the feedback, the AI engine can able to evaluate what will be the response of the people for the next webinar, and what is the likeness and current trend, and what the audience really want, and was the webinar speaker like me able to deliver a good webinar with the clarity or not. So this kind of unbiased evaluation can be done by AI, and then based on the customer experience they can able to customize the demand for that specific participant. For example, iTrain or other like USM are conducting hundreds of webinars, but you might not be interested on those 100. You might be interested on specific ones. So searching from those webinars and sending emails specifically based on your basically likeness and need is basically AI. In supply chain, there are a lot of AI like there was an autonomous truck in US from that traveled from San Jose, California to Florida, which is thousands of miles. So the autonomous truck basically go from the outskirts of San Jose in California and navigate autonomously, drive autonomously, and goes to Florida after a couple of hours. I think maybe about 12 to 18 hours. So this is basically autonomous machine using AI. Human resource, like HR. So HR might be receiving hundreds of applications or maybe more than that for a specific job advertisement. So choosing the right candidate and skill set and minimize it to, let's say, top 10 or 20. So this can be done by AI, which basically benefit the HR people to not spend time. Fraud detection. So banks around the world, like JP Morgan, like Chase, and Citibanks, they are using AI-based fraud detection, in which they will able to make sure that if the credit card or other things is being basically masquerade, then at least they will able to know how this happened. So in the future, they will not make it happen. And then there are other basically predictive analytics is another use case of AI, in which, let's say, in a manufacturing plant, there are a lot of IoT machines sending a data and running on the production floor. And then, do you know that in the production floor, if there are hundreds of machines, one machine goes down, the whole production floor goes down. It will stop. And as a result, it will basically a big loss for the factory. So the supervisor has to come along with the engineers or operators to fix it. And after fixing it, then it will run. So that can cause millions of ringgit loss. So in predictive analytics, you can able to predict which machine might goes down after how many hours. So you can have a backup plan, and you will not make production stop. And there are some pricing and promotion, like in airlines, when you are buying a ticket on specific day on specific time, based on the demand, it might increase the prices of that specific ticket. So this is all almost AI is being implemented in everywhere, and it is evolving. So what are the advantages and disadvantages of AI? So advantages is it reduces the human error, specifically in healthcare. In the healthcare, for example, a little error by a doctor can cause a life. So the cost of the error is quite high in the healthcare, for example. So artificial intelligence, using that along with the human, having a collaborative environment between machine and human, can able to reduce the error, and which will help a lot for basically in every sector. Like in US alone, maybe more than 20,000 or 30,000 fatalities have been caused because of the error by doctors or by the surgeons. Um, Second advantage is help in lessening repetitive work. So if you have a repetition work, you can able to automate it using AI. In banks, they are using RPA, which is robotic process automation. So humans are basically using to be used into critical work or something which is not repetitive. So uh, that process of repetition of the work can be handled by AI effectively. Provide digital assistance, like you have everyone have mobile device, so you can have a digital assistant and it can able to guide you accordingly, faster and more accurate in decision making. The disadvantage is there's a cost of overrun. Dredge of talent, definitely when the AI is maturing and applicable in different part of the world, then definitely it is taking a job or eating the job of humans. Lack of practical product. Somehow true, but I think there will be a time that AI will be effective in every field. So we humans has to upskill in a better way to compete with it. There's a potential for misuse, that you can able to misuse the AI for a negative purpose, like cyber security attacks or something else. Something else. So this is basically a brief introduction about artificial intelligence before we do comparative analysis. Uh, s- let's move on to ML, which is machine learning. So what is machine learning? Machine learning is basically a classification, as you know, is basically a part of AI, specifically for machines. And machines are basically hungry for data. The fuel for the machines are basically a data. So the more data machine will have, the more analytics and algorithm working on it will help the machine to make a precise decision. Just like if a person doesn't have a domain knowledge, so he cannot able to basically perform a task. And the similarly, machine needs a data and experience. So who is basically giving a data? We humans, our process, and machines, or basically mobile app or IoT. So how machine learning works? They are different kind of a data depending on what sector. So I can give an example of, let's say, manufacturing plant or factory. So in those manufacturing plant and factory, there are many sensors or IoT devices are producing the data, and those data can be related to health of the machine, like the temperature, status, the speed of the machines or devices, or they can be environmental data, or they can be a data of the factory workers. I'll give you an example of construction sector right now. There's a company called Healthy, which is in Luxembourg in Europe. So what they do is they have a equipment for construction. So the construction worker, when they are basically constructing a building, they can use the equipment developed by this or manufactured by this company. So as a construction worker are using those IoT devices, let's say for drilling, so there is a risk and health implications of using it. Like that particular machine or device can be used only 6 hours per day. Okay. So if a person wanted to use more, it will not allow. So what you do, that machine have a fingerprint scanner that will able to determine who is the person, is it an authorized person? If it is not, it will not on. Number two, one, if it is on, if it's an authorized person, then it will on and it will check how much the person have used. So if the usage is more than 6 hours, then it will able to stop and give a notification to the supervisor that this person have used a lot machine. Now he has to go back to home for rest. So those parameters which is being used and continuously transmitting from IoT devices to the cloud, and then from cloud to make a decision by machine learning and AI algorithm, it uses the data, and usually a data can be labeled data, which is structured data, or it can be a raw data, which doesn't have any proper structure or labeling. So the training set is basically is a huge amount of data that you train machine to understand its parameters. So in the future, the machine can take a decision. As you know, that big data analytics is basically having three types. One is descriptive analytics, which is about analyzing of the past data, diagnostic analytics to understand why certain thing happened, and then descriptive, diagnostic is two. Number three is predictive analytics, which is basically predicting based on the past data, you are predicting the future. Okay, so what will happen? And then prescriptive analytics, which is the fourth analytics, which describe if you can have a problem and there are multiple solutions of that problem, which solution or which decision is basically the most accurate and relevant one. So it is quite difficult to achieve prescriptive analytics. So once you have a very big data set, which might be in terabytes, so you have a machine learning algorithm. So you do the pre-processing, you are labeling the data, you are basically cleaning the data. After that, you give that data as an input to the machine learning algorithm, and these machine learning algorithms are basically statistics uh, and mathematical models for, let's say, Markov chain modeling, regression, classification, and so on. That will help in basically making a decisions. And because there might be different models, so you need to find the most suitable model, and after your suitable model and having a label, then at least you can able to do a prediction for that. So this is how machine learning works. It is receiving continuous data, let's say from IoT devices, save in the cloud, and data is getting bigger every second, and you will able to make a decision based on that. So in manufacturing, if there is a machine that needs to be in turn off if the temperature of that machine goes more than 50 degrees Celsius, let's say. So if in order to reach to 50 degrees Celsius, if it is current temperature is 40 degrees Celsius, and after every 5 minutes it's increasing 1 Celsius up, then machine can predict that, oh, it might take 50 minutes for that particular machine in that particular plant to goes down to do the thing. So it will do prediction based on the data. So machine learning have basically four types. One is basically supervised learning and unsupervised learning, reinforcement and semi-supervised learning. So artificial have AI have many branches, and one of the branches machine learning. And for machine learning, there are sub branches which is supervised learning, unsupervised reinforcement, and semi-supervised learning. Let's discuss the most common and most famous and most well applied two types of ML, which is supervised and unsupervised learning. But before I move towards that, let's talk about how and what type of things they have. For example, supervised learning, one of the mathematical model is classification that will help in diagnostic of the problem, that can help in customer retention, image classification, and identity fraud detection, especially being used in financial sector like banks. So in for the supervised learning, there is another one apart from classification is regression, which is highly used in advertising popularity prediction. Like for example, there is a website, so it will able to present the advertisement based on the region. Let's say there's a abc.com or any other vendor. So if a person is basically accessing that website from Europe, so the regional advertisement based on the interest of that person who's accessing the website will be presented. So the reference and the relevance and the interest of the customer might be different in different global region. So that's why AI will able to use the data. Data might be if you are using website, the data might be in cache or cookies about the user, what type of searching he is doing, and what type of website this particular customer is doing. So similar kind of advertisement will be presented to that. This is part of supervised learning, specifically using regression. Weather forecasting is another example. Like it's quite rainy nowadays in Malaysia. I'm presenting from Penang, so every evening there is rain. So I can able to do forecasting about what will be the weather looks like tomorrow, day after tomorrow, in the whole week. And this forecasting is using a data, weather data, which is being stored in cloud, and they're using regression for the weather forecasting. Same goes for market forecasting for product and for let's say stock exchange, and then expectancy of life, and then population growth prediction can be done by regression, which is a part of supervised learning. For unsupervised learning, we have dimensionality reduction, which is used for big data visualization, and clustering is basically used for recommendation system or target marketing or customer segmentation. Then for machine learning, third type is reinforcement learning, which is basically real-time decisions, robot navigation, and skill acquisition. So real-time decisions, which can be in the form of Google Maps as well, for example, is basically done by reinforcement learning. So what are the 7 steps uh, happen in machine learning? You gather the data. Data can be from anywhere, specifically, let's say for specific sector. You prepare the data, means you cleanse the data. You take out the irrelevant data. You take the relevant data, and you save in the database. You choose a model, machine learning model. You train that model, and you evaluate results. Initially, when you are training, there might be many mistakes. But during duration of time or passage of time, when you are inputting more data, then the machine will be basically learning, and the precision becomes higher. So you're evaluating, and then after that, you're doing hyperparameter tuning, and then based on that, you're doing prediction. We give an example of, let's say, because of time is short, let me give you an example of supervised learning, how it works. For example, you are basically having a label data. So supervised learning, you have a label data. So you have images of different species of cats around the world. And with every picture, you are basically giving data about the properties of the cat, from what is the color, what is the parameter, how big is the eyes and nose and other things. And then you are saving the data into database and you are running the machine learning algorithm. Now, if after you basically do all of this data, let's say a new data comes, let's say a picture of dog, so it will able to make a decision. Okay, the machine, after getting the picture of dog, will able to classify that this is not a cat. Or if there's an unlabeled data of a cat, then it will able to distinguish from the feature of the image, understand the parameters, and then make a decision. Oh, this belongs to cat category. So the type of problem to which it is suited is basically for classification, when you wanted to sort items into categories, or regression, which is basically identify real values like dollars and weight. So machine learning examples, they are basically in retail, like I mentioned, marketing, also in the healthcare to predict patient disease risk. Like for doctor, uh, if you go to the hospital, there might be many doctors, and different doctor might have different type of patients, and they diagnose it. But every doctor is having its own experience and knowledge that he or she is acquiring after seeing every patient. So at the end, all of the doctor are basically cannot share those information. So they are working as a silos, right? But in machine, when the machine is basically diagnosing, it's basically having a central repository or in a cloud. So all of the machine instances as an expert system can assist a doctor in a more accurate way. Similarly, for telcos, also for the customer charm, anomaly detection, preventive maintenance, and smart meter analysis can be done by machine learning. In finance, is basically fraud detection and credit card. Let me give you an example. If you ever applied for mortgage loan from the bank, it might take couple of centuries. I mean, couple of weeks, or maybe if you're lucky, maybe days. So if, why it takes longer time? Because the bank has to make sure that you are clean, you don't have any bad past record data, and you have the enough finance to back for the mortgage. So this checking of the investigation of the debt person might take longer time, but using machine learning and AI, that can be reduced into hours. And for your information, it has been applied in most of the foreign banks. And I think local banks are also moving towards this direction. If you are programming person and you would like to program something on machine learning, this is basically a slide for you to understand what are the machine learning languages. You can do C++, you can use R, and you can use Python. My suggestion will be avoid C++ because it's quite complicated and you have to write more code, more lines of code. Python is more suitable from my humble experience, because if you learn the Python, you can apply not only on AI, but you can also do programming on IoT, big data, blockchain, cybersecurity, apart from AI. So it's like killing one bird, killing multiple birds with one stone. So machine learning framework, which is very famous, are PyTorch, which is being used by Python, Keras, and TensorFlow. And then for big data analytics tool, you can use Apache Spark or MemSQL. You have to understand that Apache Spark or Apache Hadoop are basically free to use. They are open source. General machine learning framework is NumPy or scikit-learning, which are famous. And if you wanted to use for visualization, you can basically use Pandas, Matplotlib, and Jupyter Notebook, Tableau, and Vika, so on. What is the difference between AI and machine learning? Artificial intelligence is basically a superset, and the subset is basically machine learning because it's a part of AI. In AI, the goal is to simulate human intelligence to solve complex problems. But the goal of machine learning is to learn from the data and be able to predict results when the new data is being presented. AI leads to intelligence or wisdom, whereas machine learning leads to a specific knowledge because machine learning is working on specific one problem. AI tries to find the optimal solution, whereas machine learning tries to find the only solution whether it is optimal or not. So this is the ML. I still have a couple of minutes. Let us go through the deep learning. So deep learning, what is deep learning? In order to understand the comparative analysis of AI, machine learning, and deep learning, let's go for the deep learning. Deep learning is a branch of machine learning. Means that it's a type, one of the type of machine learning apart from supervised and unsupervised, based on the set of algorithms that attempt to model high level of abstraction in a data by using multiple processing layers. With that, we use basically networks, which is basically one of the most complex field in AI. You have to understand among all of the uh, pillars of Industry 4.0, AI is the most hard and complex and sophisticated. I lost a couple of hairs because of that. So with a complex structure and otherwise composed of multiple nonlinear transformations. So in general, deep learning is a subpart of machine learning that works on more sophisticated problems, which cannot be handled generically by machine learning. So there are some famous algorithm of machine learning. Among them is K-mean clustering. This algorithm assigns data points to categories or cluster, finding the mean distance between the data points. There is a k nearest neighbors. There is a hierarchical clusters, artificial neural network, logical and linear regression, and so on. And these machine learning algorithm or deep learning algorithm, they are data hungry. So you need to input a specific clean data to run on this model to get a result. What are the application of deep learning? Real-time analysis behavior, like if you wanted to check the behavior of a customer or a product, this is basically beyond the reach of ML. So we are using DL, specifically DL algorithm. Symptom-based disease identification and prediction for the humans can be used by DL. Autonomous car is basically using deep learning models and algorithm, data center security, and server optimization. What are the deep learning framework? These are some of the deep learning framework. Among them, my favorite one is basically Torch and TensorFlow. What is the difference between machine learning and deep learning? Machine learning are directed by analysis for data analysis, whereas deep learning algorithm once implemented are self-directed for data analysis, so they can able to take the fully automation, fully automated, fully smart. ML analyzes a set of pre-selected relevant features, whereas DL generate feature on its own by examining a raw data. This means that in ML, it is pre-selected in the form of supervised learning or unsupervised learning, but in DL, the machine will take its own decision, what type of relevant data it has to do. ML, a few thousand data points used for analysis, maybe uh, Excel sheet of maybe 10,000, 20,000, 100,000 maybe. But for DL, you need a very sophisticated data set. And by the way, we are not using Excel much because very slow. Okay, so we are using databases like SQL based or non-SQL based. So SQL based database are basically having a structure. Non-SQL based are doesn't have a proper structure. So in data deep learning, there are more than million data points that can be used for analysis. The output in machine learning is usually a numerical value, a score, or a classification. But in case of deep learning, output can be anything from score, element, text, or even sound. So what are the skill set and jobs? Definitely, you are attending this webinar with a purpose, and that purpose might be what is the use case? Is it relevant? Does it have any skills? Are they are having a job? So as you can see, the machines are taking over some of the jobs, and the new jobs are coming. Like data scientists, this position was not available a couple of years back. So some of the jobs are basically obsoleting. So you may not find a piece of steel beside you in a form of a robot, but they are basically invisible. You don't see them sometimes. They are in a process. Uh, like 30 years back, I give an example usually. 30 years back, when there was no ATM, if you wanted to have some money, you have to wait for the bank to open. Then you are in a queue, long queue, and after being in a long queue, then you will able to go to the counter and ask for the money. After verification they give, but ATM basically make it convenient. You can able to get money anywhere anytime, and the person, the teller in the bank who used to give you money, there's no more. So what happened? That person doesn't go back to home. Definitely once been replaced by ATM, that person upskill. So there's a continuously upskill or reskilling happening in the industry in every sector of life. So current best role in artificial intelligence, there are five which are very famous with a very handsome salary everywhere, which is AI developer, AI architect, machine learning engineer, data analyst, and data scientist. I will focus on the last one, which is data scientist, because there are so many jobs in Malaysia and other places with a very good handsome salary. And the data scientists are basically is a combination of programming, statistic tool, as well as business analysis. So in data analysis, and data scientists use machine learning to drive meaning insight from the data. So you're getting uh, quite much data from thousands of machines. So you need to convert that data into a specific purpose to get something out of it. So data scientist is basically a person who basically architect the need that is basically beneficial for the organization and enterprise. Uh, Data scientists make heavy use of statistics to identify pattern is collected data set. Now you might be thinking that, oh, I'm not from statistic and I'm not from computer science. Can I be a data scientist? Yes, you can, but there is a path, learning path, and definitely that learning path requires you to get familiar with the statistics, get familiar with programming and business logics, and there are a lot of courses available on becoming a data scientist. And if you have a different type of data set with a different type of problem, and when you identify those problems and then you solve those problems, is basically making you basic expert on that field. So usually first is data analyst, then after data analyst they can be data engineer, which is also called in some places machine learning engineer, and then it goes at the end to data scientist. So top 10 jobs involving AI skills, they are machine learning engineers, deep learning engineers, senior data scientists, computer vision engineer, data scientists, and so on. They are top. And as you can see, the average salary in US dollars is quite much. So for the data science role and how they interact, like I mentioned, they have a combination of skills from business, from programming, uh, from statistics. So when you are having those combinations, then at least you can be in a path of becoming data scientist. But of course, the first step is to become a data engineer first. So this is a basically overview of my presentation today, how artificial intelligence, which is the superset, have machine learning. Machine learning is having an algorithm like clustering, classification, regression, neural networks, and inside machine learning is basically deep learning, which have a full autonomous intelligent behavior for complex neural using complex neural network. And when this kind of a knowledge is being applied with business, then it become big data, BI analytics. Apply with the communication, become data scientist. Apply with mathematics to become uh, statistical modeling and techniques for that. So That is basically end of my presentation. This is my contact, and I think the floor is open for Q&A. So I leave this. I will transfer this uh, to Elizabeth.
Yes, thank you very much, Dr. Imran, for the very insightful presentation. And yes, so a reminder to those who have any questions towards Dr. Imran, you can ask them in the chat box on the right-hand side of the screen. And also, if you are joining in through Facebook, so you can ask the questions in the Facebook comment section. So, yes, and the presentation and recording, full recording of the webinar will be possible to see after the presentation and after you fill out the feedback form. So the first question that we have received is how machine learning can be used to identify COVID-19 genome signatures.
Machine learning requires data and data of basically the people. So in US, right now, even in China and some other countries, they are tracking basically for COVID-19 patients even before they get diagnosed, and they are basically using those ML algorithm to predict which town or which area in a place can have COVID-19 patients in the coming days. So in this way, they can able to quarantine and basically do firefighting before. So for the genome signatures, I believe that they require some kind of a genome data and some other attributes, but the data needs to be in quite much big quantity that they can able to do for prediction. Prediction analysis will be basically one of the main feature for machine learning to predict where it can be basically useful for the government authorities to work.
Okay, thank you very much for the answer. And how is artificial intelligence, machine learning, deep learning changing the education world?
Okay, that's a very interesting and good question, and I was having a discussion. There's a good news and there's a bad news. The good news is this, that teachers who are teaching in school might be irrelevant in the near future. How? Because every year they are teaching the same thing. So, with the virtual learning going towards AI-based learning, uh, there are some experiment happening in Scandinavian countries that they are giving a personalized assistant to a student who can able to answer. So instead of going to the traditional path of standard 1, 2, 3, 4, 5 and then form 1, 2, 3, 4, 5, the the there will be a teacher in a cell phone or a robot that can be personalized, and in this way those who have basically fast learning ability, they can able to finish the things and give the exam more faster and progress much faster as compared to the other students. So the question is how it will be changing the uh, education world. It is basically changing in the whole semantics of that by new learning, virtual learning and new learning based on the thing. So I think the books and the school might get irrelevant. Even they will be home-based education based on AI-based program on tablets, or there will be a robot in the school teaching them. Now, I ask you one counter question. Let's say a new syllabus or curriculum has to be introduced, which is enhanced, let's say in standard 5. So what government has to do? Government has to spend so much money on upskilling and giving training to the teachers. Okay, that require cost, number one. Number two, those teachers might need to go for training that is involving another cost. Just imagine if the robots are basically having a AR VR based education in this classroom, and you wanted to update information. It will be just with the time of click of a button. When you click of a button, updates have been made to the virtual or robotic teachers around the country at the same time. Let's say at night, in the morning, they are ready already. So that is basically where I see that there is an opportunity and direction for the education, especially in school. for that one, which will definitely reduce the time to upskill, number one. And number two, it will definitely shorten the time and cost. And then they will be a personalized teachers for the students based on their ability and based on their interest.
All right, thank you very much for the answer. So the next question is, can artificial intelligence inaccuracy be tweaked further other than feeding more data?
If you are tweaking, this means that you are doing some manual work or you are hacking. So um, my humble knowledge and experience is this, that to make it autonomous body and autonomous and unbiased, then the more data you will feed, the more intelligence and the things will be there. But there is one important aspect that I wanted to mention here. What if the data that you are feeding to the machines is inaccurate? That's why there are four V's or five V's of the data, and one of them is veracity, which means that the data should be accurate when you are giving to the machines. If the machine gets inaccurate data or wrong data, machines will be doing wrong analysis. And being based on wrong analysis, the machine can able to make a wrong decisions. So tweaking, I think, can be done, but maybe in a negative way to basically put a bias thinking and bias objective to make biased decisions. It is possible but not recommended.
All right, and the next question is, which job that you have shown is more likely to theorize about ways to further the deep learning?
Okay, if I understand this question correctly, the which job role that I've presented is likely to theorize about the way to further deep learning. Um, Machine learning engineers and data scientists. So machine learning engineers are working on statistical theory and also on algorithm, complex mathematical algorithms to basically dig further into the deep learning. I give you one example. Like there's a prediction uh, by different world bodies that machine will be writing the New York Times bestseller by 2040, means like 20 years from that. So this can be done by the creativity of the machine with the data it has, and it will able to learn and write. Currently there are some of the companies who are looking into how machine can write an article. If you give an article to a machine, it will able to give you suggestion how it can be better. So I see that using machine learning algorithm or AI developers, they are forming along with the statistics or statistician to work together to basically go into this direction.
All right, so the next question is, how long on average does it take to be a competent data scientist?
Okay, that is basically hard to say. It's a subjective question. Depends on the capabilities and the time that you have given to a person. But usually, if you let me give you worst case scenario. Worst case scenario is this, that you never did programming in your life. You might have been taught mathematics, but not the mathematics that is been required for AI. So if you are basically getting some courses from the universities, they have a special master's program. It takes about 6 months to 1 year, but it doesn't depend on how much you are basically getting the videos or listening to them. It depends how much you are applying. So the key thing in programming and the digital transformation solution is how much you have hands-on. The more you have hands-on, the more better your learning will be. So if a person is only listening but not applying, that will be wasted within one month or something like that. So you can learn programming, Python programming. My recommendation, let's say in 1 to 2 weeks, if you are layman, because there are a lot of intensive free courses in the web about the Python. And then if you go for the statistics theory and machine learning algorithm, I think it depends. So roughly I can say 6 months plus.
Okay. And so the next question is, can one person create a deep learning theory and then be able to execute that theory? Or is the amount of work greater than what one person could manage? Which position has all the skills necessary to do this?
Okay, let me scroll that question because this is very long question.
From Ryan at 10:58 a.m.
Okay, can one person create a deep learning theory? I think the theoretical aspect of anything requires a publication process by researchers and validation by the researchers and professors if they able to basically propose something because it's R&D. And once there's a proof of the theoretical aspect, then the second one will be basically uh, there will be validation process. So no one can do the invention in basically with a magic broom. You have to write a journal papers. You have to have a data proving about those contribution in mathematics, and with the result, then you publish in a reputable journal, and then you will get feedback. And those based on those feedback, if it has been accepted, then there's a new theoretical aspect of that one. One person can do. It's not impossible, but it has a long, lengthy process.
All right. So another question from Ryan. Has anyone ever fed a data set that was contrived to see the result within deep learning?
Uh, where is the question by Ryan?
Yes, 1101.
1101. Okay, last question. If we get to it, has anyone ever fed a data set that was contrived to see the result within a deep learning? There are some examples available on that.
All right. And yeah, so the next question, is there an ethics committee in Malaysia that cater on laying out the policy around artificial intelligence implementation in the industry and businesses?
Very important question about ethics. I think they are working on it, especially and MCMC and others. They are basically formulating the policy about using AI and its ethics, but I'm not sure it's been published yet or not. But in other countries, I have read for example, in Europe, they have, and Singapore also they are having it.
Okay, and the last question, is it expensive for an organization to apply machine learning uh, and data in their operations? If yes, how expensive?
It depends on three things. Number one, where you are getting the data. So it might be in the form of some files or some IoT devices. This is one cost. Number second is, or definitely you would like to save those data into a cloud. So cloud is basically another cost. So it can be public cloud or private cloud, maybe Amazon Web Service or Microsoft Azure or Google. And then when you are basically processing those algorithms, using the tools like, let's say, Hadoop or Spark, using machine learning, using Python or Scala. So when you are executing on those VM or containers in the cloud, is pay per use. So you are basically spending money on that. And the third is basically your your manpower. If they are not basically having the skills for the machine learning or deep learning, so you have to upskill them in the way that they can attend the training and that they can do. So time, cost, and then resources are the basically the skill involved to adapt the AI, machine learning, and deep learning based solution.
Okay. Thank you very much, Dr. Imran, for your time today and for the very knowledgeable presentation. And that was also the last question. And we do apologize for the ones who had troubles viewing the Facebook session. So there were some technical difficulties, but I hope that all of you were able to join here in Google Hangouts. And as well, you will receive, upon filling out the feedback form, you will receive the access to the webinar recording. So we will upload the recording within today. So yes, you will be able to see that. But yes, thank you all for joining today, and I hope you stay safe during these crazy times that we have during the MCO. And yes, if you have any questions, please write them to info@itrain.com.mi. And you can also visit our website at www.itrain.com.mi. And yes, uh, you can also follow us on Facebook to follow all the latest updates on everything. So yeah, thank you for everybody for your time today, and stay safe.